2, 3, 4 is this. That's your Markovnikov enol. Under acidic conditions, because this is, notice there's an acid here, right? So under acidic conditions, it's an equilibrium process. Tautomerizes to a ketone. Okay. See that? Sure? This hydrogen comes here and the pi bond goes there. So there are already 2 hydrogens, right? 1, 2. This also comes here and the pi bond goes there.
So that's how it could be 3 hydrogens.
Exactly.
And it
Makes
doesn't.
sense?
In my head, I immediately thought this would go
No, the oxygen.
here and make it a.
Yes, but then you'll
I'm
get
getting
stuck.
confused.
Then you'll get stuck. Is it not going to? Yes, it is going to. But see, it's an equilibrium process, and they're going back and forth, back and forth, back and forth, right? So if the oxygen got protonated, it can't go anywhere else, so it will come back here. And then this goes, so it's basically a back and forth.
And the only way for it to move
Forward is that,
Is that
yes.
okay.
So the mechanism for that, how are you going to write the mechanism? So this is not mechanism, please don't draw arrows like that, that's not mechanism. So the first step is the double bond gets protonated. When the double bond gets protonated, it makes a carbocation. Of course, there are 2 carbocations, but the more stable one is the one there. This is resonance stabilized.
Is the oxygen electron.
Exactly.
Yeah, that was enough.
Exactly. And what does this do?
To break away from
It wants to get rid of a proton.
deprotonate
With
So-
water.
So that's okay.
Becomes the ketone. So
I'm taking
protonated
pictures.
first, resonance, deprotonate,
Okay, protonate, deprotonate.
right?
Yes.
For the anti-Markovnikov one, oops, sorry.
No, you're good.
For the anti-Markovnikov one, which is under base, notice how there's a base here, right there, right? So that's under basic conditions. So the anti-Markovnikov enol, 1, 2, 3, 4, double bond. This is your anti-Markovnikov enol. Agreed?
Yeah.
Everybody?
Yes, yeah,
Right?
yeah.
But it's under basic conditions. So under basic conditions, it is also being tautomerized, but it can't be a ketone because there's no carbon here, right? There's a hydrogen here.
So it'll be an
Can't be a
aldehyde?
ketone. Exactly. Exactly. That becomes an aldehyde. The process is not mechanism, but the same kind of thing is happening. This hydrogen is going there, the pi bond is coming here. But that's not mechanism, please. What is the mechanism? What does the base do?
The
Base takes a proton. Now who's that going to take a proton from? Oxygen. That's the most acidic hydrogen in this system. So the base takes a proton from there, right?
Yeah.
What does it become?
It has a negative charge.
Good. Yes, it has a negative charge. 1, 2, 3.
And then there's resonance from that
Exactly.
charge.
This is resonance stabilized. The carb anion, excuse me, that's not a carb. The anion is resonance stabilized, right?
Yeah. And
Notice how the double bond has shifted. 1, 2, 3, 4. Now we have a double bond here. That's a hydrogen and an anion here, right?
Yeah.
See that? Now what does this need to do to become neutral?
It would bond with water, so it would take a hydrogen.
Proton, H plus,
Yeah.
right? Because those electrons go there.
So then you'll be left with the same, since it's using as like as a catalyst, it'll be going back full circle.
Exactly. And what does that become?
Anti-Markovnikov.
Aldehyde. Same, there protonate, resonance, deprotonate. Deprotonate, because you have a base, resonance, protonate. The only thing to keep in mind here is that the enols are not very stable. So this doesn't survive. It quickly becomes an aldehyde. And this one quickly becomes a ketone. Yes.
Well, since I'm assuming this is gonna be on next week's quiz for this part,
Yes.
can we just write it as like that instant thing instead of writing arrows as like, oh, it's from going to the
Yeah,
entire, okay.
Totally, totally. In fact, if the mechanism is not asked for, you don't even have to write this.
You just
You can
assume
just
it
go
will be
there
asked.
as long as you're processing it.
Okay.
If the question is asking for mechanism, then that's a different story. Yeah, absolutely.
Okay.
Sounds okay.
But you say that's not mechanism right there.
This is mechanism.
Yeah, not that up there.
Yeah, that I'm just showing them, okay, this hydrogen has gone there, the pi bond is moved.
Yeah.
But just, that's not mechanism. Yeah. Does that make sense? Of course.